Hello everyone. Today we continue to solve physics problems and in particular on laws of motion. So let us consider the following problem. We have a system of coordinates x and y. We have two bodies, one larger and one smaller, on a frictionless surface. However, there is some friction between these two bodies. So the coefficient of kinetic friction is mu k. So this top body mass is m and the bottom one is capital M. So both of these bodies are connected to a block where a massless and not stretchable rope, something like this. So the question is, what force should be applied to the bottom large body along axis x that the lower body will start to move with constant acceleration a constant. So let us try to figure this out. So in order to do that, we need to consider all forces which are involved in this case. So obviously we have weight of the top body. So this is mg. Then we have reaction of the bottom body, which is N1. We have, since this bottom body moves to the right, the top one will move to the left. We have some tension directed to the left in the rope, which is T1. So we have some acceleration in this direction, and here we have acceleration in this direction. So obviously we have tension also here in this rope. It's T2, and also we have friction, kinetic friction. F kinetic friction, let's call it 1, because this is the force of kinetic friction between the top body and the bottom one. So pretty much everything we can extend here just to have it in contact. So we need also to consider forces which are applied to the bottom body, but maybe let us do it lower because it's already quite crowded figure. So let us draw this bottom body separately. So what we will have, we'll have mg, its weight. Then we have, in addition to this, some pressure which is caused by the top body. So it will be mg. Then we have reaction of the plane where it's located. let's call it N2. Then we have our tension T2, and friction, kinetic friction F kinetic 2, which is friction between the bottom body and the top one. So keep in mind that there is no friction between the bottom body and the plane on which both bodies are located. Okay, and also we have some driving force F, which moves the body. So let us consider projections of all these forces on Y and X axis. So for our body, for the top body, small one, we have projection on axis X minus MA is equal to minus T1 plus F kinetic friction 1. So in X coordinate we don't have any forces, like more forces which are applied to the top body. Then for Y we have, it doesn't move up or down, so we have here 0 equal to N1 minus mg. Okay, let us write for the large bottom body. For X coordinate we have MA equal to minus T2 minus F kinetic friction 2 plus driving force F. Then for Y we also have 0, which is equal to N naught, or sorry, it's N2, which is the sum of weights of both body minus M plus capital M G. So now we can consider, according to the third law of motion, that F kinetic friction 1 is equal to F kinetic friction 2. I mean in absolute values. And that's why we can get the final system of two equations for body, top body along axis X, and for bottom body along axis X. So this will look like minus MA equal, oh, also I forgot, also because of the third law of motion, T1 is also equal to T2 by absolute value. Then we can write the following: minus MA equal minus T plus kinetic friction force, then capital M A equal to minus T plus, no, not plus, minus kinetic friction force and plus driving force F. Okay, from here we can proceed further, but let us rewrite this system of equations on the next slide so we have more space. So let us write it again. Will be minus MA equal to minus T plus F kinetic friction, capital AM. A is equal to minus T minus F kinetic friction and plus driving force F. Okay, now we can try to solve this equation with respect of our driving force. So we will get sum of both masses times acceleration equal to applied driving force minus 2 kinetic friction force, and this will be equal to applied force minus 2 mu k mg, because kinetic friction force is mu k and reaction of the plane where body is located, and for the top body we can write mu k mg. Okay, then the final equation for our force will be F equal to sum of two masses times acceleration plus 2 mu k mg. This is the answer of our problem. So the question was what force should be applied to the bottom body in order to move these two bodies with some acceleration, a constant acceleration a, assuming that there is friction only between these two bodies described by the friction coefficient mu k. So the problem is solved. Thank you very much for attention, and we will continue doing this in future. So if you're interested in learning how to solve physics problems you are very welcome, and continue to follow my new videos. Thank you. Have a good time of the day or night. Bye.